Hi everybody, this is Matt Ingram with another replication exercise. This time we're replicating the results reported in this Journal of Peace Research article from 2010, a geographically weighted regression. In this exercise, we'll be reproducing the results in several different environments, but this first video focuses on reproducing the results in GWR4, a standalone software package for geographically weighted regression. In order to get the data ready for GWR4, we need to do some preparations in GeoDa. So this first video is dedicated to the GeoDa and GWR4 portions of the broader replication exercise. Future videos, later videos, subsequent videos will be doing the replication in R in Python. A couple of other preliminaries. The replication data was originally obtained from the Journal of Peace Research website. There are several other replication data sets located there at that website, so I recommend that site to you if you're looking for other data sets. Also, the original replication file included only the non-spatial data. That is, it was an Excel file with the attributes for each polygon or spatial unit, but there were no spatial identifiers associated with the file. The original file, that is, looked like this. You have the province name in the first column, and then you have all of your attributes, the dependent variable, and then your independent variable, including a regional dummy coastal at the end. And the variables are described for us, but there is no spatial data here. There's no spatial code, there's no coordinates, and there was no shapefile alongside this Excel file. So in order to do the replication, I obtained a new shapefile and then restructured that shapefile, deleting and dissolving various polygons in order to align it with the replication data from the JPR site. If you're curious about the different steps that I took to do that restructuring of the shapefile, they are summarized in the replication assignment. So again, at this point, as with previous replications, I expect that you have downloaded and installed GeoDa and GWR4. We've worked with GeoDa multiple times before, so I expect that you're familiar with that environment. This is one of the a few geographically weighted regression replications that we're doing in the class. So I'll take a little bit of time to work through that standalone software package. I also expect that you've downloaded all of the data from Blackboard and saved it in a single folder on your computer or your working directory. So the steps of the replication are as follows. I expect you to open the replication assignment, the article, have those alongside you, along with the software and the shapefile and data. As you generate the following, we want to generate figure 4, which was the basic descriptive distribution of the terrorism index, or the variable labeled T in the dataset. Then you should generate some centroids in GeoDa. Add those to the table as X and Y coordinates, or the polygon centers. Sorry, that A here should be as AS. And then export the data with the X and Y coordinates as a comma-separated values file. Using that CSV file, we'll then go into GWR4 and generate table 1, which is the main set of results. We'll assess the motivation for GWR and then generate the maps of local coefficients that are represented in figures 5 through 8. So let's move to the replication assignment and the article, and then into GeoDa. So here is the article. This is the article that we're replicating. Regional effects of terrorism on economic growth in Turkey, a GWR approach. So here again, the dependent variable or outcome of interest is economic growth, and the main independent variable, the key predictor of interest, is terrorism. So we could move through various aspects of the article, but let's just move quickly to the empirics. Figures 1 through 4 are maps of different components of the terrorism index. Figures 1 through 3 are different components of the terrorism index. But figure 4 is the aggregate terrorism index, and that's the only terrorism measure that was included in the replication data file. So if we zoom into figure 4 here, it's this figure on the bottom right. We want to replicate that figure. So let's just create a window here. We want to replicate figure 4 here. So we can do this by loading the shapefile into various software environments. We've already been working in GeoDa, R, and Python. You could load this shapefile and map, create a simple choropleth map in any one of these software environments now. But let's just move into GeoDa and do it that way. Before we shift into GeoDa though, here's the replication assignment. Some brief notes about the software, where you can download GWR4 and to follow the instructions there, including downloading the manual, PDF of the manual. Here's the data descriptions of the file, and then here are the notes regarding how I constructed the shapefile. These are the replication items, and so we want to first replicate figure 4. Again, going back to that figure, it's not clear, but it looks like some kind of quantile map, maybe a quantile with 6 categories if we look at the legend here on the bottom right. So let's try to replicate that in GeoDa. And if we open GeoDa, we can see the toolbar here on the left. And let's open the shapefile that we have for this project. The shapefile is merge all. So here we have our shapefile. If you've noticed from the original article, there were 67 units that or 67 provinces. That number has changed over time, but that's the number that the authors used in the original article. Here's our themeless map. And let's just generate then a quantile map with 6 categories and see what that looks like using T, the terrorism index. And there's our map. We could change the colors into a kind of blue scale if we wanted to match the colors used by the authors. But that's a very close match to what the authors are reporting here. You can see in the southeast of Turkey there are 3-4 provinces that have high values on the terrorism index. That's the same over here. Then just north of those provinces is another unit with a high value. That's there. In the south, that sort of peninsular province also has a high value. In the center, that large unit also has a high value. And then in the southwest, we have several units with high values, and those are all reflected in our map. So we've reproduced this descriptive map relatively easily. We could reproduce multiple other descriptive maps. We could reproduce a percentile map, also of T. There it is. We could reproduce any number of other maps. If you remember some of the other replications we've done, we could do a box map or a standard deviation map, or these equal intervals maps, etc. And those might be interesting to you, interesting for you to look at, just to try to assess the distribution of this variable. We could, of course, also do these kind of distributional or descriptive maps of the other variables, including the outcome of interest. That might be the most interesting. Again, if we did say a percentile map of growth, this is the distribution of our outcome of interest, and so on. So I would encourage you to do some other distributional maps or descriptive maps so you get a sense of the distribution of the different variables and familiarize yourself with the data in that way. Moving back to the replication assignment, we want to be able to construct some spatial data, some spatial references for our non-spatial data. And in order to execute the analysis in GWR4, we need XY coordinates. So in order to do that, In GeoDa, we could generate a simple themeless map here. If we right click on the map, you can see shape centers comes up as an option, and you can add different measures to the table. If you wanted to display, say, the centroids on the map, you can see them pop up on the map there. Those are the geographic centers, or the average centers for each of those polygons. And what we want to do is to add the coordinates, the XY coordinates, longitude and latitude of those points to our data. So if we go to, if we right click on the map and we do shape centers, we could add centroids to the table. And here you can click on both X coordinates, Y coordinates, click on add variable, X centroid. If you click on the third option down, you want to add them to the add them to the table as the final column. You could add them anywhere you want, but this is the easiest to keep track of. So we'll do the same thing with the Y centroid. Just add it to the last part, to the final column of the data set. So now we can say OK, and if we wanted to, we could open up the data set and see the X centroids and Y centroids here as the last two columns in our table. The next thing we want to do is to make sure we export this as a comma separated values file. So if you go to File and pull down to the Export option, and then if you click on the folder option here, the third option down is CSV. So we want to export this as a CSV file. You could place this anywhere you want in your working directory. I have it under this replication file. There is the original CSV file that I exported. I won't export it now, but basically you could just add the name here and export, and you'll see it appear there. I'll just replace it here so you can see how that looks. But if you save it, it'll ask me if I want to replace it. Yes. I don't want to create a project file for now, so just hit export. It's a warning here that the spatial data will be lost. We want the coordinate data that's in the table, so this is not a concern for us right now. It's basically the polygons are going to be lost. So yes, we want to continue, and the export was successful. So there we are. We could close GeoDa now. Our CSV file has been saved. But one thing you might consider here that wasn't done in the paper is whether you might want to look for global spatial dependence in the data, local spatial dependence in the data. So for instance, might you want to run generate a LISA cluster map of either the dependent variable or the terrorism variable, right? We could look at the dependent variable if that's our outcome of interest, economic growth at the provincial level, and say, okay, we need to create a spatial weights file, so you might create a Queen1 or some minimum distance file or some other spatial weights file. Earlier I created a Queen1 spatial weights file, so let's just pull that one out. There it is. Again, we've done this before in GeoDa. If you wanted to create a brand new one, you could just click on this W and walk through here. You could pick out what's your identifier. ID num is a numerical version of the spatial ID, and then you could go through and pick out different forms of spatial weights: queen, rook, a distance measure, or nearest neighbor measure. I'm just going to close this for now since I've already set my default, and say OK, and then we can generate significance maps, cluster maps, and the Moran scatterplot map. Here you see the cluster map, and you see the overall Moran's eye up at the top, and then we have our LISA cluster map over here. We could increase the number of randomizations to 1,000. You see some high clusters in the north and some low clusters in the southeast, and you can see the significance of those clusters here. So again, some additional things that you could do to examine global spatial dependence or local spatial dependence in GeoDa, things that weren't done in the original article, but that you could easily execute in GeoDa. Now let's just execute a simple model in GWR4. I've already opened GWR4. It's downloaded and installed on my computer. So here is GWR4. In the first, you've got a series of 5 windows here. If you've looked at the manual, the PDF of the manual, I downloaded that from the website. It has step-by-step, very practical, step-by-step instructions about how to go about filling in each of these tabs. But just let's walk through one model quickly. You can call this session anything you like. I'm calling it just Rep4 as Replication 4. We want to load our data from this is our CSV file, so you want to load this CSV file. Open. If it is a CSV file, you can call it that, a CSV file. You might have saved it in tab delimited format or in space delimited format. You have other options for doing that. It might also be a DBF file. You could import the DBF file and see if it reads it. I've in the past had some trouble with CSV files and DBF files, but this CSV file seems to read just fine. If you're having trouble, then transform it or reformat it into one of these different formats and try it again. But let's click CSV now, as this is a CSV file. You can also open it. If these fields are not populated already, they will be populated when you click open. And you can see that you've got 67 areas. That matches the number of polygons or provinces in the data. And then we've got 28 fields or variable columns, those vertical variable columns. You can quickly take a glance at the first 10 lines or at all of the data. Let's just look at the first 10 lines. And there it is, right? Object ID, the name of the province, and then we've got all of our data, replication data, right? The dependent variable here, growth, the 1987 income, the base level income, terrorism index, education, government expenditures, and whether the unit is a coastal unit or not. And then here we have our x coordinates and our y coordinates. So we can close that and move to tab 2. Here in the ID space, we want to enter our spatial ID. That's the numeric spatial identifier. So that goes here. In the x coordinates and y coordinates, you want to enter those that we just generated in GeoDa. So there we are. Keep the projected version and then keep the Gaussian version. We can talk about these other options later for different types of dependent variables, count variables, binary variables. There's some extensions here from the basic model, and we're using projected distances. Also leave these unchecked. These can take a long time to generate, and it's also not always clear whether you want to generate these, but for now let's just run through the basic model. So we've got our main specification set here, the ID number, our coordinates, and then we want the dependent variable to be growth, and we have our main predictors, the base level of income, terrorism, education, government expenditures, and coastal. So let's just grab all of these and bring them in here. You can grab them either each one at a time or grab multiples using the control button, or use the shift key to grab them all from top to bottom and move them over here. So this is our model. We've now have it specified. Then we want to pick the moving window or the neighborhood around which these local calculations are going to be made. I would just select any one of these top ones. The default is usually adaptive by square. That's the number of neighbors. So it's going to pick a number of neighbors, and it's going to move through and generate the calculations by the number of neighbors. And then leave the default also golden section search, and leave the default for the model comparison criterion, this adjusted version of AIC. And then in the output, you need to say where this output is going to go. To do that, I suggest you generate different folders for each of the models that you specify. So I've created this folder here, GWR output, and in here I've created 4 different folders for the 4 different models that I've run on this data. This is our default adaptive bisquare, and in this folder you want to create 3 files. An output output.ctl file, an output_listwise.csv file, and an output_summary.txt file. You could generate any of these files just by generating a new file or a notepad and just changing the extension. Just generate any new file and change the extension to CTL, CSV, and TXT. But the name should be output, and then output_listwise and output_summary. You need these three files in order to proceed in GWR4. So here we are in the fourth tab, and if we hit browse, we can go to GWR4 adaptive bisquare, and you'll see now, you can see the control file. You can double click on that. You want to replace it, yes, and it should automatically, in the next two spaces, it should automatically update the other two files. And here you can see that it has done so. It's placed the output_summary.txt file as the summary file, and then the geographic listwise file, the file that's going to contain your local coefficients, or the estimates for the local coefficients and significance values, in this output_listwise.csv file, output_listwise.csv file. Leave the other parameters unchecked, and then we can just go to the final tab, the fifth tab, to execute the file. And here you can see that I've executed several files already. If you hit execute, it'll execute this next file and that your next model, and you see that it just took maybe about 5 seconds to do so. And here are our results. So we can scroll up to see all of the results. You can see this is where it started. Program began at 2:52. And then it has some summary info and the output some basic summary statistics. The global regression result is your OLS model. So this is your OLS model. You can see that it has your estimates here, standard errors, and t-values. So these are significant if they're larger than 1.96 or smaller than -1.96. So you can compare these findings to the findings reported in Table 1 in the original publication. We could go to Table 1 and compare these findings. Right? This is the global regression result, is the OLS model result. And then if you scroll down, you'll see the GWR results. It conducted a search to find the best size of the neighborhood to use for the analysis. You'll see that it's found 52. You could compare this to that reported in the original publication, which was 8. You see here underneath Table 1. So that's different. And then you see the parameters for the geographically weighted regression. This is the mean estimate for each predictor. You'll see the minimum value for each predictor, the maximum value for each predictor, the full range of estimates for each coefficient, the lower quartile, the median, and the upper quartile, the interquartile range, and some other statistics looking at model fit or model comparison. These are all of the values that are reported also in Table 1. The minimum value is the second column. The variable name or variable label is in the first column. The minimum value is in the second column. The lower quartile is in the third column. The median value, the OLS or global regression result here, the upper quartile in the second to last column, and in the final column, the maximum value. And as the authors discuss, the original motivation for the GWR, if the motivation for the GWR is correct, then we should see some added value to examining the local variation in each coefficient, as opposed to examining or estimating a single average coefficient for all 67 units. So how do we know if there is added value to estimating the local coefficient as opposed to simply accepting a single average coefficient across all units? We know that in part by examining the interquartile range. This range from the lower quartile to the upper quartile, 1.48 to 1.536, the interquartile range is approximately 0.05, and that range covers 50% of the values, right? The 25% of the value is below the median, the 25% of the value is above the median, so that gives us 50% of the values. By extension, or by comparison, if we looked at the OLS estimate and one standard error, we would have, or one standard error on either side, we would have approximately 66% of the values. So if 50% of the values gives us a wider range than, say, 66% of the values, then we can conclude that there is some added value to examining the local coefficients. This would be even more true if the 50%, if the interquartile range, or say of the local coefficients, were even outside of 2 standard errors, or the 95% interval. So if the size of this interquartile range from the lower quartile to the upper quartile, and the comparison with it to a 1 standard error range or a 2 standard error range around the OLS estimate, gives you a sense with the GWR output, the GWR4 output, of whether there's some added value to the GWR analysis. We'll see that there are some other methods for motivating GWR. In R, for instance, we would do some simulation exercises to estimate more precisely whether the local coefficient is statistically different from the average coefficient generated by OLS. But for now, let's stick with the results provided by GWR4. So here you see the interquartile range, as we said, was about 0.5 for the base predictor, the base variable. And we could go back to the global regression results, and these are the global regression results, yes. And look at the estimate and the 1 standard error. So 66% of the values would be between -0.31 plus 0.07 and -0.31 minus 0.07, or from essentially around -0.38 to -0.24. And here you say that 50% of the values are between -0.53 and -0.503. So that's quite a difference. And you'd have to go through and examine these coefficient by coefficient, but we can talk more about this in class. But this is essentially the way, in using the output from GWR4, you would motivate the GWR analysis. Is there some difference between the distribution of the local coefficients and the distribution of the global regression or OLS coefficients? What the more informative way of looking at these results is to map the local coefficients generated by this analysis. And if we go to our output, we can look at these 2 files. The output summary file is exactly what we were just looking at in the GWR window. So there is a permanent file generated with all of the summary output. But in the output listwise file, we see this. Here we have the area, the unit identifier, the coordinates, but then we have an estimate, a standard error, and a t value for each unit and for each predictor. So for instance, here is the estimate for terrorism, the terrorism index. This is the local coefficient for terrorism across each unit, the standard error, and the t value. So this effect is only significant in each of these units. Each unit is a row. This effect of terrorism, of the coefficient for terrorism, is statistically significant, where this t value is greater than 1.96 or lower than negative 1.96 if we're looking at the 95% confidence interval. You can see, for instance, that this coefficient is significant here in this unit. It has a negative effect and statistically significant. What is useful about these values is that we can take each of these values and map them in the shapefile that we have already and visualize these results. So I'll do that in a subsequent video. Thank you.